Hello and welcome to my final Mechatronics 210 project. I am Team RoboDobo. This is me on the right side, and all the work done in this final project is done by myself. At the beginning of the semester, we wrote a program using Blockly to enter a specific angle in decidegrees and use the cosine of a quadrant function in order to get decidegrees back. The next project of the semester involved making a robot arena so that the robot had an enclosed area to move in. I used three pieces in order to make the walls of the arena that included the measurements on the left-hand side. When combined using glue, it made the wall that is on the right-hand side picture. The next piece of the robot arena included the two floors that the arena would need. On the left-hand side is a simple 60 by 90 board that has measurements of 10 centimeters on the horizontal and vertical axis. On the right-hand side is the board that is used for the QTI line tracking during the final project that has the measurements shown. The final project was about QTI line tracking that involved the robot going counterclockwise around the left circle and then clockwise around the small circle back to the starting point in the middle that made a turnaround. For the QTI line tracking to work, it requires many functions such as a clock, the QTI array that allows the sensors to run, and the positive edge detection so that everything can read the clock edge. The function wheel speeds on the bottom is primarily used throughout the code so that the wheels know what speed to move at. The function wheels reverse is the inverse of the function wheel speeds, and the function wheel 180 is used to turn the robot around. In order to force the robot to going to the left or right during critical moments where it has to change which circle it follows, I created two functions called turn left and turn right that prioritized either the left or right sensors depending on which action it was going to do. The function turn 180 is a set of instructions that makes sure the robot is on the starting position and stopped before the function wheel 180 turns the robot around, and the function wheel reverse makes sure that the robot is on the starting position after it turns around. The code on the right is the full set of QTI instructions without the case values of the sensors involved. The specific case values of the sensors are the default ones assigned during the lecture, but I did add two cases for 1011 and 1101 so that the robot, once it was meeting the fiducial point, didn't start to veer off and go straight ahead when it shouldn't be. In order for the robot to know that it was at the starting position, the case 1111 was added. A set of instructions were included in order to make the robot do specific actions depending on if it needed to go to the left or right, and it used a counter variable called half loop in order to give these instructions depending on where it was in the run. Once the robot reached the end and half loop was equal to 6, the robot would correct itself and make sure that it was at the starting point, and then the robot would stop driving, and the return function was used for the program to end itself. And now to show you the entire code of this, I will show the video run that I got of the function being executed correctly. That is what was done within this semester of MCTR 210. Thank you very much.